What's up, guys? Distance and midpoint formula practice. So for this bad boy, you're really going to want to have a calculator in front of you. We're going to be doing a lot of stuff in this calculator. We're going to be learning some stuff about this calculator. And I'm going to tell you right now, questions like numbers 3 and 4 are really not the easiest without a calculator. And you might be saying, well, I'm more worried about, I can use my phone calculator here at home, whatever. I really recommend practicing with the one at school. Don't forget, you're always allowed to ask me to take one home to borrow. That's not an issue for me. Let's hop right into it. So distance and midpoint formula practice, our midpoint formula. So first of all, what the midpoint formula is going to be our x1 plus x2 divided by 2, our y1 plus y2 divided by 2. And in terms of what this means, it just means the first x value added to the second x value and divided by 2. Let's do that nice and slow. Here's our first x value and here's our second x value, and then we're going to add those together. So -3 plus -1, and that's going to be -4. So we add the two values together, and then after that, we divide by 2. So after that, we take that -4, and I'm going to do a math heathen thing. I'm going to write the divided by 2 like this, and sure enough, I get -2. So that's kind of like the really slow way of doing it. And we're going to do exactly the same thing with the next one because actually no, I'm gonna switch colors to another way of talking about it. Let's do x2 or y2, sorry, or y1. Oh my gosh, Mr. Richards. Y1 and y2, our first y value and our second y value. So on this one, I'm going to do it more the formula style. So the more formula style would be like this, where I take the -6 and I add that to the +2 and I say divide by 2. Now, when you're writing this out for yourself, remember there's basically invisible parentheses around all fraction numerators. There's like invisible parentheses like that. So if you wanted to, you could actually put those up here, as well into your formula. After that, -6 plus 2 is in fact going to be -4, and then divided by 2, and that's also -2. So the midpoint for this particular question, our very final answer, is the ordered pair, the x's and the y's. Our final answer, -2 comma -2. Now we had all that work. That's all well and good. But I actually think this was a waste of time for this one. Maybe not a waste of time for the -6 and 2, but if I asked you, like, I'm going to go for a second here. I'm just going to say to myself, what is the middle of -3 and -1? I don't think anyone would question that it's -2. Of course, it's smack dab in between -3 and -1. What number's in between 2 and 4? 3 is. Same exact idea. That's all that's happening there. So if you notice stuff like that, I don't need to see any of this work. I think you know that between -3 and -1, the middle value is -2. And that's what's happening for the first value of this next one. So pure formula this time. Pure formula, no extra thinking about it, no other stuff. Let's just do pure formula. X1 is equal to 10. Our Y1 is equal to -10. Our X2 is equal to -10. And our Y2 is equal to -4. Remember that this is our X1, Y1, X2, y2, and like I said, I'm just using the pure formula method for this one here. That pure formula method will end up looking like so. We're going to have our big huge parentheses. We're going to have 10 plus -10 divided by 2 comma -10 plus -4 divided by 2. There we go. And instead of doing any actual work, now I'm going to use my calculator. The reason why is my calculator's got this nifty feature here that will let us use fractions. So to make the fraction show up, you actually have a couple different options. On the newer version of this calculator, you can just hit alpha x and it just goes. However, this one doesn't have that little green symbol. So a calculator at school, you can just hit the alpha and the x button and the fraction will show up. On this one, in the older calculators, you instead have to hit alpha y equals enter. If you do alpha y equals enter, that beautiful fraction shows up. On this one, we're doing 10 plus -10 divided by 2, and we're going to hit enter on it. We're going to get 0. And that's what I was talking about, that this one was an obvious one. What's in the middle of 10 and negative 10? Of course it's 0. Anyways, after that, alpha y equals enter, we got that negative 10 plus negative 4 divided by 2. And, well, let's just do it in our head really fast. Negative 10 and negative 4 is going to be negative 14. Divide that by 2, and you'll get negative 7. Oof. All right. And now this one, probably thinking, Mr. Richards, are you kidding me? These are the most obnoxious fractions in the entire world. Why in the world are you doing this to me? You probably hate us. No, we're going to learn to use the calculator, because sometimes the calculator is just going to be the best option because of how obnoxious your formula is. So let's just do that. X1, Y1, X2, Y2. We're going to make sure we write it down first before we plug it into the calculator, so we know that we're plugging the correct thing into the calculator. So our answer is going to be our x1, 3 over 4, plus our x2, 7 over 4, all divided by 2, comma, and then we're going to have 9 over 5 plus negative 2 over 9, all divided by 2. Always divide by 2 for these formulas. And you might be asking, Mr. Richards, that negative was in front of the fraction bar. Why'd you put it on the negative for the 2? That's a great question to ask. Cute little note for it. Negative in general, if I have something like negative 2 over 9, that's the same exact thing as negative 2 over 9. And that's the same exact thing as 2 over negative 9. So all three of those things are identical to each other. In general, we're going to use the first two way more often than we're going to use that last one. It does occur sometimes, but not needed. So like I said, we're going to go ahead and do all this in the calculator in a single step. Well, I guess 2 steps, because we have a 1 for x and 1 for y. We're going to do our alpha y equals enter to get the fraction. And then after that, we need another fraction. Another one, alpha y equals enter. We got the 3 over 4. And then we're going to go ahead and plus alpha y equals enter. We got 7 over 4. And then all divided by 2. And I got to admit, if you're watching this right now, you should be taking a calculator out and trying to hit these buttons for yourself to make sure you're able to do it. You don't want to get into the middle of a test or a quiz and not know what to do. It won't be fun. Then we're going to hit enter. And boom, we get 5 over 4. Comma, and then I'm doing the same exact thing for the y's there. We're going to have, looks like alpha y equals enter, another alpha y equals enter. We have 9 over 5 plus alpha y equals enter, negative 2 over 9 divided by 2. We get 71 over 90. Beautiful. There you go. That's the whole problem. Now, you can go ahead and like fast forward to the next part of the video if you don't want to hear this, but I'm going to explain how you could have gotten to that 71 over 90 by hand in the event that you just like felt like it. Maybe you're just an Uber nerd and that's what you want to do. So if you do want to do it by hand, what you're going to do first is you're going to add the fractions at the top. So in order to add those fractions at the top, you want to make common denominators. The common denominator between 9 and 5 is going to be 45. So you'd actually be multiplying this one up here by like it would be like 9 over 5 multiplied by a 9 over 9, and you'd be adding that to negative 2 over 9 times a 5 over 5. However, there's a great trick for doing questions like this where you can kind of do all of this work in one step really, really fast. And what you do is you multiply the edges out here, the 9 and the 9. And that's going to give you 81. And then you multiply these edges, the 5 and the negative 2, and then you're going to add that, negative 10 there. And then on the bottom, you're just going to multiply these two together, and you get 45. So you'll notice that would have happened anyways. 9 times 9 is 81, 5 times 9 is 45, negative 2 times 5 is negative 10, and 9 times 5 is that 45. And don't forget, all of this stuff is still divided by 2. All that stuff is still divided by 2. Continuing on, you end up with that 71 we talked about over 45. But one of the big things is if you're doing everything divided by 2, dividing by a number is the same as multiplying by the reciprocal. So in other words, dividing by 2 is the same thing as multiplying by a half. So we're going to go ahead and multiply that by a half, and sure enough, we get 71 over 90. If you cared, that's how it came to be. Next one's all calculator. This one, same exact idea. I'm going to label these ones. You do not need to label them. If you are getting to the point where you're super comfortable and you know exactly what's going on, you can. I do require you to write down the actual formula part of it, though, so that I'm certain about what you're plugging into the calculator, especially if you have an itsy bitsy typo. You type in 9.302 instead of 9.203, and then your calculator gives you the wrong answer, and I give you a 0 if you show no work, or I can give you most of the points if you show this work here. So we're going to have 9.203 plus 2.9 all divided by 2, comma, always divide by 2 for the midpoint, negative 9.713, 9.7, see what I mean? You got to be careful. 9.713 plus 5.5, and that's divided by 2. And yet again, we are just using our calculator. That's a 7, by the way. It's the same number as this one. That's what goes there. Okay, and now we're going to use our alpha. Y equals enter 9.203 plus 2.9, all divided by 2, and then we get 6.5015. And that's how many decimals you do for AP Stats. So that's what I'm going to do here. If you are in planning to go towards AP Calculus, you'd actually write 6.052 because you go to 3 decimal places in AP Calculus. You could also write 6.051 because you can just chop off the end of the number in AP Calc. And if you're trying to do something for a science class, you want to do significant figures, you'd actually write 6.1 because you only have 2 significant figures here. So just a note, that's acceptable. You could have done 6.051, 6.052, or just 6.1 if you're doing your scientific significant digits rule. All right, after that, alpha y equals enter, and then we have negative 9.713 plus 5.5 divided by 2, and we get negative 2.1065, and that is all she wrote. Moving on to the next one here, number 5. This is exactly the same problem as the previous one, except now you're on a coordinate plane, and you got to figure out which coordinate is which. So we're figuring out which coordinate is which here. So I'm going to go ahead and label this one the first one. Please note, if you decided to label that one down there as the first one and this one is the second one, all your numbers are flip-flops, but you'll get the same answer. So it's not like it's a problem to do that. You could have easily said that coordinate down there is the first. And that first coordinate there is going to be negative 1, comma, positive 2. If you are wondering why, it's because I counted left 1 and up 2. So left 1 and up 2. Likewise on this one here, I didn't move left or right at all. So this one right there, that second value, that one's going to be 0, comma, negative 4, because I didn't move left or right at all. I just went straight down to negative 4 using our midpoint formula. Our midpoint formula is going to say, let's scroll up like this. Midpoint formula is going to be our x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And we end up getting negative a half, comma, 2 and negative 4 is negative 2, divided by 2 is negative 1. And I'm going to go ahead and put it on the graph there. So let's do negative 1 half, negative 1. So negative half, negative 1 is right there. And sure enough, that looks exactly like it's in the middle. Maybe you could have eyeballed it. Maybe you could have just jumped right to the answer. I wouldn't risk it, but I think I'd risk it on this one. This one, I think the answer is so obviously 0, 0 that that's like definitely in the center, right? Like it's 4 up, 1 over, 4 down, 1 up. Let's just prove it with our math there. It's definitely going to be 0, 0 as our final answer. But just to make sure that we're doing it right, we can have negative 4, comma, negative 1. So we have negative 4, negative 1. And then we have after that positive 4, comma, positive 1. So our formula would be negative 4 plus 4 divided by 2, comma, negative 1 plus 1 divided by 2. And that's just going to be 0 over 2, comma, 0 over 2, which is just the answer we already talked about, 0, comma, 0. Moving on to our next page here, we have question number 7. Now this one requires us to do a little bit of algebra, but we could also avoid the algebra and do a little bit of a thinking thing. So I'm going to explain it the first time with only algebra. I'm going to do the second one with only thinking, and then I'm going to do the same thing on numbers 9 and 10. I'm going to do the algebra, then I'm going to do the thinking. Both options are 100% legitimate, and yeah, that's all we need. So here we go. It says the endpoint is 5 comma 4. So this is effectively our x2 and our y2, and our midpoint is -10, -8. Now normally the way that we write this is to say that we have an x middle and a y middle. There's going to be two different equations. Remember, the overall formula for the x's was x1 plus x2 divided by 2, and that was the x middle value. Before I plug anything in, I want to note one of our big algebra rules. One of the big algebra rules is if you move sides, you switch signs. So a big dividing by 2 is the same thing as multiplying by 2 on the other side. So I could say x1 plus x2 is equal to 2xm. And now I can just plug and chug because we have x1 is the one we don't know, and we're adding that to, in this case, 5, and that's going to be 2 multiplied by that negative value, -10. 2 times -10 is -20. Subtracting 5 on both sides, you get x1 is equal to -25. After that, for our y value, I'm not even going to do that dividing by 2 right away. I'm going to do it slightly different. I'm going to show that part later. So same exact idea, though. Y1 plus y2 divided by 2 is equal to that middle y value. We don't know what y1 is. Our second y value is 4. And then we're dividing it by 2, and we're going to end up at -8. Just like I was saying on the last one, at this point in time, you're going to want to multiply both sides by 2. But if you're going to like show all the work for it that way, you'd be kind of do it like this, where you'd multiply by 2, multiply by 2. That cancels out like so, and you end up with a y1 plus 4 is equal to -16. Then we'll subtract 4 on both sides, and you'll end up with y1 is equal to -20. We have both of those answers, but our actual good final answer, we want to make sure we actually write the entire coordinate. So let's write it out, -25, comma -20. This is like the better, let's box it to make sure we're like super certain that that's the one that we want. There we go. Now, like I said, you could do this one this way. You could do it the thinking method. Now, what I mean by the thinking method? What I mean by the thinking method is that we're going to have an x number line, and we're going to have a y number line. Let's check this out. So our endpoint is at -3. Actually, we're going to have 3 points here. We're going to have an A, B, C. We're going to put 3 collinear points. Oh, yeah, using that vocab, baby. And the midpoint is -1, but we're only using the x's. So I'm going to go -1 right there. Okay. And for the y's, same exact thing is going to happen here. The midpoint is 7. Now it says the endpoint is -3 for the x. So -3 would be on the left-hand side. And 5 would also be on the left-hand side. Sometimes they'll actually be over here. Maybe it will in the next question. Let me double check something really quick. Well, I'll check in a minute. Either way, the whole idea here is that this distance from here to here is 2. And because it's in the middle, that means that this distance must also be 2. -1 plus 2 is, in fact, our final answer of +1. Likewise, this distance right here is 2. Which means that this distance here is 2, meaning that this final answer here, 7 plus 2, is 9. So our final answer here is going to be +1, comma 9. Some students might say, but Mr. Richards, y goes up and down. Then draw your graph up and down, you know? You have fun. I did it left and right. Whatever. We're going algebra again for number 9, and then we're going to go back to this one, but I said I wanted to check something. Is my midpoint smaller on either of these? Yes, my midpoint is smaller, and this I'll be good for my other example. All right, good. All right, number 9. So number 9, again, I'm doing all the algebra version of it. So the algebra version, it ends over here. Our x2, our second x value is that 5. Our second y value is that negative 10. And then our midpoint, our x middle is 3, and our y middle is 0. Doing it 100% algebra style. My preferred way is how I did it first, where I multiply by 2 before I plug it in. So I'm going to start from right there. That's actually my preferred place, but I'm still going to go ahead and write the formula because that's all you're really going to have on the actual test. Over 2 is equal to xm. And then we're going to multiply both sides by 2. And we're going to have x1 plus x2 is equal to 2 times xm. And the same thing will happen for y, by the way. So I'm just going to go ahead and draw a line down the center here. And we're going to have y1 plus y2 is equal to 2 times ym. Same exact concept, but yeah, kind of just keeping myself occupied at this point. All right, so x1 is the one that we don't know. By the way, if you wanted to feel even fancier with it, you could actually just move the x2 over immediately. I'm just choosing not to. Plus 5 is equal to, and then, did I make a mistake on the previous? No. Is equal to, so 5 and negative 3. So 2 times negative 3. Put it in parentheses probably. I should have put the other one in parentheses up there. I just didn't. So let's put that in parentheses. That's the smarter thing to do. Likewise on this one, I really should have put parentheses around that negative 10. Anyways, that's going to give you negative 6 over here. X1 plus 5. And then we're going to subtract 5 on both sides. And if we do subtract 5 on both sides, we get negative 11. Same exact idea over here. We don't know what y1 is. Our y2 is going to be negative 10. 2 times 0. There's my parentheses. You get 0. Y1 plus negative 10. Add 10 to both sides. Y1 is equal to 10. Final answer, negative 11. Comma 10. Yet again, I was trying to say before, some of these answers are obvious. If the midpoint's 0, then one's negative and the other one's positive. So negative 10 and a positive 10, you could have jumped right to the answer. Let's do my thinking point way again for number 10. I bet you at this point in time, you'd much rather do my little short version than this, but this one's going to be a little bit different, so let's check this out. So we have an x right there, and again, we're going to have our 3 coordinates, our 3 collinear points there, and our end point is 6, but we're going to start with our midpoint. We always start with the midpoint with this method. The reason why we're starting with our midpoint there is it's negative 6, but it ends at positive 6. So our other ones over here, same exact idea for y before we start. Our midpoint is going to be 8. But this one, the endpoint's negative 5 because negative 5 is on the left-hand side of 8. So just kind of important to keep that picture nice and neat to make sure you're not like confusing yourself or something. Now, how far is this distance here? Well, if you don't know how far a distance is, in general, it's always right minus left. So distance in general, we're actually going to learn another formula in just a minute. But for straight line distance, our distance here is always going to be our right minus the left. And that will always be the case. Or you could also do top minus bottom. That's the other way of doing it. So our distance in a straight line, one dimension, it's always right minus left or top minus bottom. 6 minus negative 6 is 12. So again, 6 minus negative 6 is 12, which means that this distance over here is also 12. So our ending point must in fact be, negative 18, negative 6 minus 12. Likewise over here, the same exact concept. We're going to be doing our distance 8 minus negative 5 is the same as 8 plus 5. That's going to be a total of 13, which means that this distance here is 13, and 8 plus 13 is going to be a total of 21. Our final answer, negative 18, comma 21. Beautiful. We're moving on to our distance formula. So moving on to our distance formula, find the distance in each pair of points. I went through an entire thing in class about why this formula is the way it is. However, I really recommend for you that you just have that formula kind of memorized. If you want to figure out and really understand it, you can figure out what the formula is even if you forgot it. But this is one that shows up so often that you often want to even skip that remembering and figuring out step and just go directly into that answer. So first of all, our distance formula is going to be the same. I'm only going to write this once because it's the same on every single one of these questions. So we're going to have our x2 minus x1, all of that squared, and we're going to add that to our y2 minus y1, all of that squared. And then after we add those up, we're going to take the square root of the entire thing, and that's it. So just doing that really quick, our distance here, we're going to have our x1, our x2, our y1, our y2. So our distance there is going to be like that. And we're going to plug in what we got. So our x2 is -3. Our x1 there is 5. And then we're going to square it plus big parentheses here. And then we're going to have -7. And then minus -1 and all of that squared. At any point in time, you can use a calculator for bits and pieces of this. However, it's really important that you don't put that square root into the calculator until the very, very last step, and it will be more clear as to why in a little bit. So -3 minus 5, all that squared is going to be, excuse me, -8 squared plus -7 plus 1, because -7 minus -1 is plus, -6 squared. Our distance there is going to be -8 squared is 64. Positive -6 squared there is 36. And our distance there, the 64 plus 36 is 100. And our distance is equal to 10. However, I do want to say you're allowed to use a calculator. If you write this, you can jump directly to the answer if you just plug it into your calculator. Let's watch that happen really fast. If I go second square root and I just type all of it in as it appears, -3 minus 5, big parentheses squared, plus -7 minus -1, all of that squared. So I typed it in exactly like I wrote it down, and then I just hit enter. We get a nice little 10 answer, and you didn't have to do any work. So you could have jumped right to the answer and it was okay in my class. However, when you have decimal answers, it ends up not being okay. So let's check that out. Let's see what I'm saying on this question. So on this problem, our distance answer is going to be same thing, x2 minus x1. So we're going to have -5 minus -7 all squared plus, and then we're going to have y1 minus y2 all squared, just like that. However, if I were to throw this one into the calculator right away, I get bamboozled because it's not going to be an acceptable answer for what's called exact. So we're going to have -5 minus -7 all squared plus -1 minus 0 parentheses squared. You hit enter and you get this decimal. Decimal here is going to be not okay because it's an irrational number. It's going to be an approximation. There will be times where you're asked for an approximate distance, and there will be times when you're asked for a distance. When you're asked for a distance, you do need to give the exact answer. So what you're actually going to do is you're going to plug it in without the square root. So we're going to go ahead and do our -5 minus -7 all squared. So -5 minus -7 all squared. And then plus our -1 minus 0. By the way, did you really need to put the -0 in there? Probably not. Could have done it like that and you get 5. And that is the actual correct answer, is the square root of 5. This is the one that we want. You could say that it's approximately 2.36, 2.2, whoops. D is approximately 2.2361, correctly rounded there. However, it is still an approximation. You can go look it up on a website like Wolfram Alpha, and if you look it up on a website like Wolfram Alpha, it can give you the square root of 5 out to 1,000,000 decimal places. This number does not stop right there. It actually goes on forever and ever and ever. You know, it's Yeah, like I said, it's a really big number. It goes on forever, and it doesn't actually stop at that 7. It goes on and on and on. So we want this answer. We don't want to answer like this. So this is good. This is no good. In general, however, there are some times and when we are quote unquote living in the real world. In the real world, this actually might be a good answer. You know, if you're building something in a wood shop class and you need to have a square root of 5 length, that's probably going to be okay. Anyways, I'm going to stop talking there on that. We're just going to move on to our last two questions, numbers 13 and 14. Same exact concept. We're going to use our distance formula there. Our distance formula is that big, huge square root, but we need to figure out what are our two coordinates. So our two coordinates here, we have a -1, and then we didn't move up and down at all. So -1, 0. And then we also have +1 to the right and down 2. So our x2 minus x1 all squared plus, and now we have our y2 minus y1 all squared. However, I do want to point something out about this distance formula that might make more sense. This right here is how far apart you are on your x's, and this right here is how far apart you are on your y's. So your x's here, how far apart you are on your x's? If you notice, the x's, how far apart you are, is 2. And that makes sense because 1 minus -1 is 2. So right minus left. So we have 2 squared. And then now, this part right here, how far apart are the y's? Well, the y's are also 2 apart. So that's also going to be a 2 squared. Now you might say, but Mr. Richards, that's a -2 squared. Well, -2 squared and 2 squared are the same number because you get 4 either way. Regardless, 2 squared is 4. 4 plus 4 is 8. And we write the square root of 8. And this is the right answer. This is the right answer for an AP Calculus class. It's the right answer on the ACT. However, that ACT is also allowed to present it differently. The reason why it's allowed to present it differently is like a bonus topic. This bonus topic is really kind of focused towards honor students. So if you're in a non-honors class, you can kind of skip it. However, if you're an honor student and you're trying to get that perfect score on ACT, SAT, future classes kind of stuff, you do need to be able to rewrite the square root of 8 in a different way. The reason why is there are actually certain square roots that we're able to divide out. And here's the idea. The idea is twofold. First of all, there are certain square roots that you basically just have to memorize. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. At this point in time, you might be saying, I know that, Mr. Richards. Yeah, well, you need to memorize all these probably up to like square root of 400 if you really want to be good at it. So if you don't have these down pat already, let's start getting the show on the road. Start getting real good at this honors level math. And I believe in you. And maybe make some flashcards, maybe a little Quizlet for yourself. You know, whatever it is. And hopefully you don't have the same number theory teacher that I had when you're in college, because my number theory teacher made me memorize all of them up to 100, as well as the cubes up to 20. I'm going to stop whining. Will I ever stop whining? I don't know, but 121 gives you 11. 144 is equal to 12. We got 169. Square root is going to be 13. You can see I'm like writing sideways here down the page. I apologize. I have no reason for that. After that, we got 196. Square root is going to be 14. We got 225 equal to 15 there. And square root of 256 equal to 16. Square root of 289 is equal to 17. You thought I was joking about having all these memorized. No, it is not a joke. 324 is equal to that 18. 361 equal to the 19. And you're finally done at 400. Can't even see what I wrote. Point is, you need to have all these memorized if you really want to be good at a question like this. If you want to just avoid questions like this because the only reason it was ever taught this way is so that you could do this stuff without a calculator, is specifically building a woodshop thing without a calculator. If it was like, you know, back in the 1950s or something, there was only one way to do it. More on that later if you really want to hear about it. But the point is that 8 can be written using that square root of 4, because the square root of 8 here is the same exact thing as the square root of 4 times 2, and that can be written as the square root of 4 times the square root of 2. That's a general rule of thumb for square roots, actually, that so long as your numbers are not negative, negative numbers on the square roots do weird things for complex math. It's literally called complex analysis. That's the name, complex numbers. But in general, if you have the square root of a times b, it's the same thing as the square root of a times the square root of b. Other than that, square root of 4 is 2. And this one is square root 2. So if you look this up in like an answer key of this problem, you'd actually get 2 rad 2. And that would be your final answer. And if you decided to plug all of it into your calculator because you can't handle doing anything else, you could also say approximately 2.8284. Okay, I ranted. I'm done ranting. We're going off to question 14. Finalizing it. Here we go. What's our first coordinate here? We have, so you can make sure you can see it. Yep, we got -5 because you're going over 5 up 1. And then our other coordinate here looks to be +4 comma -2. And our distance is going to be the second x value minus that first x value all squared, plus we have the second y value minus the first y value all squared. And I'm just going to do this one all by hand to show something about the previous topic that I showed. So if you're somebody who is not in honors, again, just plug all that into your calculator and get right to the answer right away. What's that going to be? Square root of 90. You can just write square root of 90 and move on with your life. However, if you want to see something else, check this out. So checking this out here, we're going to have 4 minus 5 squared is going to be 9 squared, and -2 minus -1 is going to be 3 squared. Again, -3 and +3 squared are the same thing. And then after that, we can, before we do anything special, we can rewrite 9 squared as the same thing as 3 squared times 3 squared. That's a general rule of thumb you can do for exponents. You can kind of just divide them up like that, because 9 squared is 81, 3 squared is 9 times 9, whatever. Point is, you're allowed to do this, and if you do that, now we can use our reverse distributive property, our factoring, and saying that this is the same as 3 squared multiplied by 3 squared plus 1. Now, yes, this is still square root of 90. There's nothing wrong with that. However, because this is the square root of 3 squared, I can rewrite it like that. Square root of 3 squared times the square root of 3 squared plus 1. Well, the square root of 3 squared is just 3. You're square rooting something squared. They're going to cancel out. Times 3 squared is 9. Adding 1 is 10. You get 3 square root 10, and this is like that final perfect answer, or really maybe 3 rad 10, maybe that's the better way of writing it. Either way, square root of 90 is still full credit, and actually it will be full credit even in the honors class, but if you're really pushing yourself to be really good at math, that's how you'd rewrite this one. I will say one more thing. On this particular question, another one of your teachers might have taught you the quote-unquote tree method. The tree method would have looked like this. You would have ended up with 90, and then after that, you would have went ahead and divided by your prime numbers the best that you could. So you probably would have done 2 maybe and 45, and then you would have done maybe 3 and 15, and then after that you would have done maybe 3 and 5, and you're supposed to circle the pairs, and the pairs come on the outside as a single, and on the inside we get times the square root of 2 times 5, and you get 3 rad 10. You might have remember doing it that way. This just takes even longer than this or this, and really just start getting good at it. I'm going to stop ranting now. Have a great rest of your day. Peace out, guys.